6 margaritas without us before this. Let's just
I
point
just
that
had
out.
one.
I'm jealous.
Right?
That I wasn't invited.
I am
This is
so
the same
sorry.
thing.
Is there an unofficial social now?
It could be.
Are we going to have an official social where we all show up an hour early and meet it?
And maybe the bar or the margarita.
Sorry, Michael.
I know I'm going to Frankenstein's after this.
Okay. I have to talk with Cassie about some that stuff.
They did. Drama law.
Oh gosh.
Miss it. I think we had the most productive conversation that. We did.
Have
Well,
you been here longer?
what?
Does the meetup start at 6:30?
Usually starts at 7, but it says 6:30.
Well, this one has always started at 6:30, but we always start a little later. So 7 was too late because we have to be out at 9, and the first one or two that we had went all the way up to 9 and pushed
I think there's something
beyond.
to be said for leaving when people want to do more. But we'd also do more meetups and just have it be a continuation, like have like the first meetup be a talk.
Awesome.
Scheduling the spaces.
Yeah, it's always coming up with a day that conflicts with the least overlap type of meetups. So ML, because no one wants to come on a Monday or a Friday or Saturday, so all the meetups pile on Tuesday, Wednesday, Thursday. You really can't find a day that's the first, second, third, or fourth. Some people do last Tuesday, Wednesday, Thursday of the month. So when picking our date for this one, we picked the day that had the least likely overlap, which was Orlando front end.
Okay, that's fair.
Right?
Yep, front end is not complaining. Yeah, a pretty small audience tonight, although I know we might have a slightly larger live stream than usual. Definitely be on that. Definitely. That's Casey. You might not know, but she co-organizes the meetup.
I did know that. I just wasn't there, like, one more person.
There's one more person. So we can just get started.
It's not
then.
actually my first time using it. I wouldn't have recommended it. Any type of festival,
I am all for that.
at all of the graphics. Oh, yeah, I love it.
Yeah.
That's awesome.
Huh.
How dare you? Unacceptable. We're up to so much right now.
Yeah.
You ready for Bob?
Ready for Blob. I replaced Blob.
I know.
You were so proud of it.
I know, I wasn't. I couldn't believe you posted that.
You left it there, so I went, okay. Cat's a dog. Yeah. So, Atlanta Machine Learning and Data Science. And actually, let me switch over to that. Let me double check that it's right. Yeah, that's good. So, Florida PyCon. Woo! Yay, Florida PyCon, same day, but we have an amazing site. Logos emerging. Thank you, Aaron. It's awesome. We have, so tickets go on sale in 2 weeks on the 21st. We have a mailing list, so I don't have to bug people over Slack and meet up anymore. Yay. And call for papers is open. Submissions close on September 1st. We'll give people about a week to vote on the talks that they are most interested in, and we will have an event schedule crafted, probably only a couple days after voting ends. Woo. So, just kind of running right into it. We have a data set. We have an amazing data set, cats and dogs. And this is straight off of a Kaggle, an old Kaggle competition. Yeah, let me see. It should be right there. So this is from, it started 4 years ago, ended 3 years ago, roughly based on the dates that were on the page.
Yeah.
Yeah. Yeah.
It's there for the data. Yeah, I don't know. They have really
Yeah, that's really the best
They're like,
reason.
exactly.
Competitions are nice. You get to see how other really technical people were able to solve it and get 99% accuracy on something that's insane. But yeah, you just want a clean data set, or you want to point people to the standard machine learning and model training data sets right there. You don't have to download R to get them.
Adorable.
Cats versus dogs. So 3 years ago, and it is as simple as you are given a ton of images of cats and dogs that have corresponding labels of 0 and 1, and you must write a model that is able to be given a photo and say, this is a cat, or this is a dog.
Dun, 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 dun.
Yeah, the data set's clean. And for reference, the final leaderboard, they were able to get it up to almost 99% accuracy on the the test and validation. No, I think it was just provided a test. So, as an example, here is a puppy. Or is a kitten? No, that's another dog. Silly thumb. The brain can make mistakes too, especially when the information is in a thumbnail. This is definitely not a dog. It's a kitten. So, based on the sizes there, we will have to do some amount of data manipulation. Off the top of my head, I can't think of a model that will just narrow in on the dog or cat's face. So if we can't figure that out, we might just have to crunch the entire image. Not terribly hard.
So Google has that big project where they were able to identify different dogs based on pictures. So they might have
That was a Microsoft one, actually.
Oh, is it?
The application that we played with, that was Microsoft.
Excellent. That means the tool will actually be open, not behind the API wall.
Maybe. Azure has a free tier, just like Amazon does, and Google up to a point.
I think it's good if something
That's text. There we go. So this is our training data, and conveniently, our labels are part of the file structure. So cat and then index. So we just read in all the cats, read in all the dogs, strip out all of the file names. If it starts with cat, we give it a 0. If it starts with dog, we give it a 1. And we have our data set.
And we don't.
Hey.
Bye. Oh, hey. Fantastic. I used it. Okay, yeah, you have to take 5 seconds to set up and then it was, just, what was it? Blue? That one, stochastic. Okay. So we're not starting yet?
Okay, we're just kind of doing an overview of it right now. Just this is our data set, and we have a bunch of photos. I'm not entirely sure how many, but I think we have an even number of cats and dogs. So our data set is roughly 25,000 images. We'll see how well my Mac does. It's a MacBook Air, it's live streaming, and it's to be running a neural network. We'll see. So, and I'm not going to be on the computer this whole time. We're going to try to have other people come up as well, like we've done at the Python meetup. So just know that when you are up here, your face is going to be in a tiny box in the bottom of the live stream, forever immortalized on YouTube until we get a takedown notice for some ridiculous reason. So, we were talking before, we might do this in Keras, unless anyone else wants to try a different technology. We only have 2 hours. All right. So, I already have a Jupyter Notebook session up, so we can create a new Python 3 notebook. Cat dog. Yeah. So, first thing we need to do is get our data set in, and think in glob in order to do that, so we can grab all the cats and then grab all the dogs.
I love Bob.
Glob. Thumb out.
It's, I presumably a mob program. Yeah.
Yeah.
Let's cover that.
So- So in a pure form of mob programming, the person who is at the keyboard is actually told what to type and does not input at all. But there's so few of us, so I don't think that's going to be a problem.
Pair programming must go.
Yeah,
Exactly.
exactly.
So like something I could be like, hey, I need a refresher on Glob, could you pull up the documentation for Glob real quick?
Yeah.
And then you would do it.
Yeah. You get documentation up here. Everyone else is looking up documentation. Yeah. So, quick refresher, because we need to get our files in and create our data set, or create our data set in our actual code. Pull up glob. Oh, and if we don't finish this tonight, would you guys be interested in either, not next month because you want to talk? Okay, we can also continue this for the next meeting as well. So, Python. I always love it when the Python 2 documentation comes up first in the search result as opposed to Python 3.6, which is the current one. Anyway, so very simple. Glob, from glob, import glob, and we give it a path name. You give it bash or Unix style path names with asterisk, wildcard characters, and all of that. And it will just give you in Python 3, gives you an iterator of all of the different file names that it was able to pull up. So, let's go into a different tab. So, from glob, import glob. And I'm grown accustomed to putting our imports in a separate code block from the code that we try to keep running. As opposed to, oh my goodness, I went to PyCon and all the data science stuff, they just said, I don't really care what I'm working on right now. I just have all of my normal imports, normal data science imports, and I'm going to make that the first giant code blob. They imported maybe 20 different data science libraries and ended up using 2.
Ew.
And I saw this on at multiple different talks. That's just a pet peeve of mine. They don't import things you don't need. But whatever. Cats equals glob, and then we're not currently in our folder. We're in the data set that we want is in train. So we would have to start off our file name with train. Parentheses, single quote, train, and they all start with cat, so we can just do cat wildcard. And for the sake of just seeing if it works.
Cats!
Cats! We have so many cats. I always love how it does that. Everything just looks like lines when they're all the same length. Anyway, we can copy that over for dogs as well. And they just start with dog. So now we have actually, I think glob gives you a list. It doesn't give you an iterator, or it just whatever. We now have a list of cat file names and a list of dog file names. You want to print out dogs?
Yeah.
Okay.
I do want to see all the dogs. I tried to resist, but
Oh, let's actually use consistency there. So there's the dogs. Woo. Woof woof woof. So here's the fun thing. We can already create our labels from the data that we have right now. And or let's actually do label cats, label dogs. Label cats. Fun thing about Python, you can multiply lists. So if we just say that 0 stands for cats, we can just do times len cats. And we now have a list of n number of zeros, which is our corresponding labels for each cat image. And we can copy that over for len dogs as well. And we give them a binary encoded label of 1. And later on, because we're using Keras with, for convolutional neural network, it would be, this is the equivalent of doing one hot encoding. So you have one output node for a dog, one output node for cat, and we just take which node, the index of the final nodes. So run that, and whoa, I have not seen that before. I don't know what just happened. Well, I don't. Possibly, yeah, probably. But I've also never seen this line marker there before. I probably just hit something and it enabled internal lines. It probably is something in view. Maybe. Nah.
so what do you want to be
Tons of zeros. Actually, it's. We'll get to this later, but we'll definitely have to import NumPy and encase all of these zeros inside of their own list. Actually, what if we just do that? And then label cats. That's actually what our data needs to look like. So we have a list of all of our image paths, and we have our final separated labels. We'll eventually combine them together and do a shuffle. Yeah, I think just a regular shuffle.
need to apply the label to
Because the label for the image cats index 0 is the same as what would eventually be, or I guess what is label cats index 0, then everything stays in the same order. And when we combine our final data set of here's all of our labels, or here's all of our images and here's all of our labels in a single set, it'd be something like all of the cats, all of the dogs, labeled all of the cats, all of the dogs, where they all line up by index. And then when it gets sent into sklearn's shuffle, they keep the same index. So then we can then feed it into our model.
that means we have a success.
Yeah. We have our labels. Let's read in the actual image data, and then we can have someone else come up. So for actual image data, we should probably use well, we can use CV2 ImRead. Let's see, forget my exact import, but from CV2 dot image, I think. Yeah. Let's see. No, I think it's just Imread, but let me double check this. It's saying it doesn't like CV2 is not a package. I ran it early. See, so it can import CV2.
Michael?
Yeah.
How do you connect to Wi-Fi?
Oh, the Wi-Fi is PIY guest. And Dave will write it up for you. So, documentation time because I haven't touched CV in about a month. Let's see. No. That's just it.
You want to
I can bring this back there. It's still going to stay there. This pen Python, that wasn't Python. I could pull up Find Me and just see what I had done before. Yeah. So import CV. Okay, so it's not under image. It's just import CV2 and then CV2.imread. Might be able to do from CV2 import imread, but if that gives an error, then we'll just do CV2.imread.
on the off chance that we have to do any documentation, we can just do later.
Just import. All right.
And then use it because it's got a lot of other documents.
All right. So I might going to just delete because I don't know what's going on there. So, and probably do what is it? I think it's matplotlib inline.
Yeah, document.
No, I think there's a space. I'm just wondering if there's a space before. I think there's no space there. So let's do that. There we go. So let's do yeah, we'll just read in our first cat image. So cv2.imread cat's one. And then, yeah, I think it's cv2.imshow, yeah. Ta-da! Okay. Oh, I was thinking matplotlib or something like that. Rebuild the library with Windows on a Mac.
Seems like a problem.
That seems like a problem.
So that is actually bypassing. Scroll up.
No, nor you would have to create a. Well, you don't have to create a window. What they're doing here, ImShow, what ImShow does when it's not in Jupyter Notebook is that it will actually open up a new window. And this wait key says keep the window open until I click on the window and then destroy it. Oh, this is part of the OpenCV docs. I just searched OpenCV and read Python. I'm sure someone on the stream is just yelling at us right now, but.
Anybody has comments on the monitoring the Slack channel?
Well, I will quickly cheat. This is why we keep old code around.
This is part of the process. This is part of
Yeah.
through a complete process.
That's true. Hmm? It's in Meetups at the very bottom. No, I definitely posted it. Possible that it's slow Wi-Fi because the live stream is taking up a lot of bandwidth. I definitely posted it. That's just taking forever. What do you know? Oh, that's what interesting. So instead of using CV2, I was using Matplotlib, ImRead, and ImShow. There's actually a difference between ImRead between Matplotlib and CV2. One of them, and I don't remember which, opens RGB, and the other one opens BGR with an alpha channel. I think Matplotlib is the one that opens up RGB, and CV2 opens up BGR. Don't quote me on that. But that they were using imsave. It should just be the same thing, but I'll just do Matplotlib for ImShow. So Matplotlib pyplot plt. So then we just do plt.imshow, and I think you just give it the image instead. Hey, look, we have a cat.
Yay!
All right. Ooh. So,
Is that like, I would never use Matplotlib instead of
well, you're using Matplotlib to actually,
right.
we're technically to graph the picture. Matplotlib does have its own ImRead, which we technically could use instead of CV2, but we thought of CV2, and it works. It still ends up just bringing in a 2D array of No, technically a 3D array because pixel values are RGB. So, or yeah, so it ends up bringing in they both end up reading in a 2D list of RGB or BGR pixels. So once the data's in, Matplotlib can just imshow. So we know that works, and we have our actual image data in. For the sake of, if you can hear how hot the computer's running right now, and that's true for every live stream. What if we limit the number of images that we read in to either 500 or 1,000 of each kind? 500 or 1,000?
500.
500? Yeah. Yeah. So let's read in 500 from each set. So our training data will be 1,000. And we can do cat features, dog features, because now we're actually reading in actual feature sets. So for this, we can use a list comprehension because we're just going to read in the actual image data for each one. So we can do cv2.imread cat for cat in cats, and double that for dogs. Yeah. So all this is going to do is just create a new list of the actual image data that will be read in for each file name in our list of file names. And let's call that feature dogs. Oh, and we add up to our limit. Otherwise, we would have been reading in all 12,500 of each of them. Let that churn for a little bit. I'm very glad that I brought my plug with my computer because this would take twice as long. I noticed when training a neural network, it takes twice as long to do it if you opened up the Jupyter Notebook when it was on battery. Because when you plug it back in, but you don't reboot or you don't reload the Jupyter Notebook, it still has that limitation on it that it's only going to run at half speed. We have images. Let's quickly do a plt.imshow for features cats. I like 42. There's a cat. And dogs.
Ah. Are we sure?
3, 2, 1. So I think the CV2 is reading it in BGR, and then it's doing this. I'm curious if we have CV2 there, but kind of peek back over here, matplotlib.image. So what if instead we do from matplotlib.image import imread, I think, yeah, because I think CV2 is the one that does BGR, and then Matplotlib thinks that it's RGB, which is how we get Blue Dog, or Blue Dog's not there anymore, but this cat is probably also going to look a little different. Green eyes. So let's see how it looks on this one. So we'll do our import there. That looks a little more like a cat.
Oh, much better. Oh, that is so different.
Yeah. Yeah. So yeah, so CV2 definitely reads it in BGR, and Matplotlib reads it in RGB, and then just assumes that it's RGB pixels. So we'll let it recrunch. Takes about 15, 20 seconds. And then I will change this one back down here. Well, let's see what the dog looks like, and then I'll switch it back to 42. Let Blue Pup have its revenge.
So, can I just kind of, I'm not such, like, can I summarize a little bit, or can you help
Oh,
me
sure.
summarize?
Sure,
Exactly what
sure.
So, are we just training this basically to look at the picture and be able to read what's in it?
That's exactly what we're going to do.
Okay, and then eventually we're going to look not at the pictures in our database, but at any other picture on the internet. And that's how we're going to do it.
In theory, when you train it, and it should be able to just identify what's in it. The hard part,
Yeah.
so yes, if you train it, there's an entirely separate data set in here, which is the testing set, which our training data set hasn't seen. It's still manicured. It's still a manicured data set, but it's still trying to guess things that it was not trained on, which would be true to real life.
Got it.
Doing.
Different channels and bigger pictures. So the importance of having an accurate looking picture is that it's using all three data streams, like the red, green, blue, to make those assessments of what the cat and the dog as well as the black and white. So we are teaching it how to see the images itself, and then the next step is to identify. Okay.
Interesting.
That's half the battle. Or like even 80% of the battle.
Did I say that you pixel on? Wow.
This is a double look. One for this amazingness going on over here, and the other one because I ran the code block without getting rid of CV2 in front of the inmate, so I have to wait for it to do it again.
Oh no.
It's like, this kitty is so blue.
So the way that they measure is like again on top of it. The way that they
Yeah. And now we'll check out Blue Pup again. Yeah. Zoom.
Whoa. Out of 10. Much improved.
Much improved. Yeah. So we have our data, and I think it's time for someone else to be up here.
Woo!
Yeah, been up here for about 30 minutes. So we have our,
Hey, over there.
yeah,
Funny guy.
we have our final labels, and we have our images read in, and they are ready to be used. The next step is pre-processing, which is going to be a little interesting because we don't have time to do some of the really fancy stuff. And we need to figure out how to take these images, which are of different orientations and pixel values, like resolutions, and say, we're going to squish you into a 45 by 45 or something standard that we can read, that we can use as input into our neural network, because the input layer has to be the same size for all the input data. That's gonna be the next challenge. So who wants to come up here? And we'll still be yelling things at you for you to type.
Yeah, eye contact.
You were a teacher in a different life.
I have been a teacher before.
Oh, that one. I can type, you just have to dictate to me what I'm typing.
That's
That's all.
actually, so my goal is not to use that as an example of a mob program.
Oh, really? Just trying to do it on
The
thing?
person in your role is actually not supposed to contribute ideas.
Oh, we're just supposed to type and
But-
do whatever you say. No problem.
Although you are welcome to add ideas. You totally accept that.
I'm happy that I'm on track with exactly what is happening. So I'm good where I'm at. Thank you.
So, we need to figure out how to do size manage. So let's look back at the student documentation.
What am I doing? Scrolling up? Oh no, I see.
A different tab in the browser.
This guy.
Did you want to do that, or did you want to go from parents that pre-process?
Ooh, that's what you think for us.
What are we from what?
From parents that pre-processing.
Care.
K-E-R-A-S.
Okay. I'm sorry. I didn't hear that.
Import pre-process. Okay.
And then to make things easier down the line, also add
Uh-huh.
KP.
Okay.
So we don't have to type out pre-processing. And then it's shift enter to run the box.
You.
You did it!
Yay! All right.
Alright,
Gold star?
so can you tell us more about how to size manage using pre-processing? It's like, you can, if you want to see, if everyone wants to see,
Parents pre-processing.
yeah, Keras.io/pre-processing/image. So we're looking at the image data generator. So that would be a line that all we would type is kp.image.image data generator. And then we would pass in.
A lot. I
Got
think
it.
what they're showing on there is
The default value. So all we have to pass in is hey. Yeah, the rescale.
Rescale?
Yeah.
Okay. So no, come on.
I can like read it out too. So kp.image data generator.
kp.image, image data generator.
And then parentheses.
and we should make that very variable.
What do you want to call it?
Like,
To make it a variable, go to the front of your line, so in front of kp,
Mm-hmm.
and then type in kp_rescale equals.
Oh, I'm sorry. I know how to do that. All right. And then what am I calling on?
Um,
Rescale.
I want to go back.
I
Yeah,
was
I
going to
think
be discussing.
So the thing with this is that we actually need the size of our largest node. We would need to pass it in a pixel size. Let's do 300 and see what happens.
Okay.
After the pre-process,
If you can change the node size and aspect, would be under the background of like very manipulation. The image itself is
I'm reading through the documentation and not entirely sure, but there actually is there's a call that needs to be made to and there are code examples at the bottom of the documentation file to call it data frames, and then when those names fit on the entirety of the training data, the training feature set, and it uses that to optimize what should be going through the data before it gets passed to the actual model.
Because if some of the images are, if some of the training images are square and others are like 2 by 1, then
yeah, that's what we're trying to do. Yeah, yeah. Also do.
well, well, but somebody obviously takes that problem before. So
Good time for Let's, because I like exploring, enter that, and let's see what happens, and then let's Google how to rescale.
Default to none. It's none or 0 and apply. Otherwise, we multiply the data by the value provided before doing any other thing. So it's a pixel value multiplier.
so this there,
Yeah. So they do have things in here like rotation range and width and height shift range. It might be a little bit more what we're looking for. So that's so things like height and shift, range of shift.
for the training data that we're working on, do we have this model? Or
We do, the view that we opened up, they do have this.
It's a mix of
Yeah.
horizontal and
Look, we'll show.
with all sorts of different resolutions.
Yeah.
So like that one was,
This one's 300 by 300, but then this one is 400 by 500, 300 by 500.
And even using this system, I don't know if you get it down to say all of these images that we're passing in are going to be of such and such dimensions.
That's why we would want to find the largest photo that we have in our set. However, it's not really like we can only apply that to what's in our data set. We can't then like later on.
there's a thing called flow mode. Once outside the values of the
And you probably want that to be constant as opposed to linear.
because what are the other columns? AP and or detail. Yeah, probably their example uses data gen. And either way, data gen, we fit it to training data or training feature set. And we would then, it's a generator. So instead of doing our traditional train, we use model.getGenerator and pass that, pass those down as a first function.
So what are the first?
This would be something else. What? Yes. This I'm sorry, I said yeah, but I didn't mean. What am I doing? I'm sorry.
For now, we can just get it empty set of parentheses and come back and play it.
Okay. What are you saying, Amy?
It's not important that
It's the yeah, exactly. So
Oh, is the neural network going to work on television images or?
that's what I was talking about with three different channels. It's an activity by data as well.
Also, so we will use the color.
Yeah. One thing that we can do, well, what needs to happen regardless of whether you do RGB or scale is going to take this image file and flatten it into a single list of 0 through 55. And then that gets put 1 to 1 for our input array.
If you use studio, that's the color.
The way when we completely flatten each image in press for being set into the normal list, it actually would go R0, G0, B0, R1, B1, B1, and pixel by individual RGB channel pixel values, the 3 and next 3, all the way going into the single layer.
Well, the really good.
Okay, so the, like the first three elements of the list would be for the first pixel.
Ideally, what we want to do for image analysis is just add lists of zeros to make the map. We can use all those. But for now, for MVP, I was like looking at elements as well.
So yeah, we can use those. So we just get that. Yeah, so we have an instance. Oh, that's fine. Okay.
oh yeah, it's doing. Oh yeah, it's really hard to see up there.
So.
That just means it goes.
Well, that's important. Well, and then just rerun the profile.
Oh. Do I have to retype it?
No, you just select
Click on
click into the
34.
folder, and then you do different folder.
Got it.
So say if you comment that out, comment that our KB underscale, underscore line,
All right, got it.
and I guess we can go ahead and do the DIR.
You mean to do it on a separate line?
Yeah, we can go into the one box. So DIR.
Not a comment?
Yeah, this is
Sorry.
DIR parentheses AP. Sure. So this printout is everything that is inside of our pre-processing module. And that code block should be able to scroll. Or no,
What?
what? It has nothing in it. That's it.
Whoa, that's freaky.
Yeah. So let's do import Keras. And
No ads.
Yeah, no ads. Import Keras and then do dir Keras.
DAR?
DIR.
Like directories.
Oh, got it. Okay. I know how I say it in my head. It's not the same way you say it. There we go.
Yeah, that's things. There's pre-processing. The pre-processing is in there. Let's go back up to our DIR. And let's add dir Keras dot pre-processing.
Dot pre-processing.
And there's nothing in there. I don't know how to check the version from
What, if you go to the community, you said you did Keras.
So swipe over to the left so you can get, or I guess just go to the bottom of the
Right, just-
terminal.
Yeah.
We need to do terminal. That's where we're using it.
Oh. New window?
And then just type in PIP space web. Okay. And
What am I looking for?
yeah, so we're looking for Keras is alphabetical.
Keras 2.0.2.
2.0.3.
Where was I before? In Safari?
You need to check the version of the documentation you're looking at. So this is for the 2.0.3, but it still says the image is being pre-processed. Also, I'm not convinced that this is exactly what we need. So I think this is more where I just want to overstart and I want to add some more to it.
Okay.
Let's go to, so the process that happened by adding straight up zeros is we create, transform zeros into a zero list, compare the length, and then apply extra to those. So let's go through the motion of that.
anything that should be using for an image processing pipeline to create a function of the process, take them in the image, the center pad, get the zeros, and then rescale it with center package with CDP on the side, or Japanese or something like that. With we can scale it down to 45 by 45. Or two center pad.
Working on
Center pad is more likely what we're looking for. So center pad sounds like it would just have zeros right on either end of it, as opposed to this might be all the pad zeros down to the on.
It's not, the word sounds like it's had in the center.
Where? Here? No, over here.
I think function means that we're going to keep the original image in the
Must
center.
be CV2.
Now, I was thinking inside of the center pad sounds like you're adding the center pad. Not the opposite.
How to pad a matrix to make it even sized in Python.
Not the best. They're not my favorite naming conventions in all of programming.
If you do command shift plus, it will increase the font size.
There we go. So we can actually read it.
Yeah.
Oh, can you guys see it now? Okay. Okay. New tab, CSV2. CV2, right? Am I hearing you wrong or are you saying it wrong? I think you're saying CSV2. No, I'm hearing CSV2. It doesn't matter.
I think about CSVs when I think about data a lot.
Yeah, I know, me too. And so I'm like typing it, but I don't. Doesn't matter. Sorry, what am I looking up? Document.
So if you look back at the slide, looks like it was make borders.
Right in here.
So the bottom of that code block,
Copy, make border.
copy
Okay.
Go back here to tab and search for copy make border.
Copy. Adding borders to your images.
Let's do it.
Boom.
And then basic operations for images might be a helpful place to go if this is not what we want.
Okay. Pad the image with a constant. You don't want to do that. You want to go back and see what's next?
This requires an actual like black box.
Yeah, we don't want that.
Yeah, go back to basic image functions.
Basic operations on images. Okay. Alright. Accessing and modifying pixel values. Let's load a color image first.
There's two functions called mid border. It says I want to add.
I'm concerned about anything border.
So it just says how many pixels do you want to add to your top right, bottom left of the image. So if you just say I know that this image is taller than it is wide by
opposite, or
Some are horizontal and some are vertical, right? So you need to use one that's all in straight.
Yeah, I think that would be, we need to get it to be a straight aspect ratio.
So it's almost needs to be, that is left and right.
Yeah. So
Okay,
let's create a function.
all right.
So
Tell me exactly what's that.
DEF is a binary function.
Okay.
Space. Let's call this one pre-process. And
Okay.
in parentheses, it takes an image, so IMG.
All right.
And then outside, we colon and colon, and then we challenge it. Oh, no space.
No space. Oh, isn't Python really weird about spacing?
It is, we're not going to be able to run this until our function is done.
Okay. Oh, then our function's not done yet.
Yeah. So, yeah, this is it.
Okay.
So for the sake of, okay, so we need to get the height and width of our image, which in this case, this is able to do with,
CSV dot height should be a function CB2 dot height.
Yeah.
CB2 dot.
where it
Do we need to? Sorry.
uses, in dot shape. So, img dot shape, and then do colon, inside of brackets, square brackets.
Brackets? Nope.
Yeah.
Do colon.
Colon 2,
Okay.
or, no, I think we actually need, we need to do 2 colons. So, if I recall, yeah, I think shape does,
You can only print it out and see what it
yeah,
is.
yeah, this is,
That's helpful.
yeah, so let's get rid of the brackets there.
Get rid of the brackets?
Yeah.
Yeah, type on that line instead of that. Go to the
Oh,
front
just
of
print?
it. No, that's fine. Okay, from here, print. And then you hit dot,
In parentheses, yeah.
and dot.
Do I need parentheses after this? I'm always unclear if I do or
No,
not.
this is a data structure, not a method.
Okay.
And so now so there we go. And let's do pre-process. So we'll call it a pre-process function by typing pre-process. And then in parentheses, we'll give it features underscore cats.
Oh, features underscore 0.
Cats.
Cats.
And then bracket.
0. Because we're calling. I got that. Got it. Woo.
Okay, so another thing. So
So the first one is that. The first one is, let's print out the image as well. So we can,
yeah, let's
like
do that.
that's
Should I go back up here and just do it, or?
No, just,
I think we already did, no, we gave it one. Yeah, so this one is plt.info.
Oh yeah, because we're not doing it.
plt.info, and in parentheses we do features
I know some stuff sometimes when I'm told exactly what to do.
okay, cool.
This one is wider than
Oh, my poor cat. He does not look happy. All right. Hey, can I ask, what does the 3 at the end mean? Oh, it's because we have the 3 colors. Oh my god. Wow. Well, I knew it was like in 3 space, but all right, cool.
So, technically speaking, our image is a
Three-dimensional.
image, at least as far as computer.
Why?
I think it's historical precedent. When we first Jews were
then
Or
project
no,
four,
like project 4. And project 3. Oh,
so you're drawing everything. Yeah, computers draw on project four
And everyone has kept the standard.
why?
I don't know.
because people keep conventions.
Well,
You can blame the math more or less.
It doesn't matter, but it's interesting to know. Because, like we were talking earlier, like I'm a pure math person, so it's like, why would you even do that? Because
Well,
it's not causing.
You thought that
Yeah.
it was the row number from the column number. So you could, that you could put, adjusted that difference.
Okay.
I don't think people.
Yeah, that makes sense. Row by column. Okay.
now that you said it like that, I will be able to remember this much better.
Okay.
Yeah, that's actually really cool. Yeah, row by column.
Yeah. And that is actually what your printout is. People, when you call in shape, they'll use the number of rows per column. That's exactly what it is. So on the outside, it's rows, so it's counting the height because it's the overall thing, and inside your row, it's the individual columns within that row.
Every linear algebra class I've ever taken is better since now. If I could have known this 10 years ago, that would have helped. But okay, that's,
It's probably this is because of
yeah, because that was all, yeah.
And if you ever forget it, just remember that Mac came before Windows, and whereas Windows, your start button is where you would think would make sense in quadrant 1.
Mm-hmm.
But the Mac has it really before Windows, and theirs is where the 0 would be in quadrant 4. And so everything starts in quadrant 4 talking like that.
Square me off there, have that locked down, and then box it up.
Keep going.
Oh, logic behind everything. Okay, cool. That's helpful and
So,
informative.
we can go back to the function and say, now we now know our height and our width. Or, yeah, so, yeah, height and width. What we can do is, back up your function.
Our function.
Pre-process.
Yeah.
This guy, yeah,
pre-process.
here.
So, instead of printing it out, we can do H, comma, W equals in that shape, and then we have our bracket.
Got it. Bracket colon 2, because I think everything. No, 2 colon, right?
No, colon 2.
What-
We want this to first to.
We're just doing
Up
first.
to the third.
Okay.
Yeah. So we now have our height and width. So we could do a if statement to say if the height is greater than the width, we're going to add our width, else we're going to add our height.
Yeah.
All right. I do it on the same line, right? If height greater than or equal to width. Cool.
Actually, you don't even need to equal to because if height equals width, we don't do anything.
Oh yeah, because that'll happen in the else part of it, right? Okay. If height is greater than width.
We'll need to
Yeah,
know
let's do it now. Yeah.
So the first case is if the height is greater than the width.
Yeah.
We can add the width. And if the width is greater than the height.
They go to the next one.
And then,
Mm-hmm. Okay, so then we're gonna add the width, right?
yes, so we're going to have the width. And if you guys want to look at the documentation on this, it's actually on the getting started with OpenCV equals tutorial that they provide. basic operations on images. About halfway down. Halfway down. Making borders.
Yeah, where am I going?
Oh, so this is on. Actually, it would be easier to do OpenCV, Python, basic operations. Yep. And all the way to the very bottom, let's say, here's an example of 5010. So really what we want to do is, like the last image that has the red rectangle around it, which is just say, hey, I don't care what the actual contents of the image are, which is what the other ones are looking at, the other nodes. We just want a constant which is going to be a 0, comma 0, comma 0 for a pixel. And just above that is the documentation for it.
Here?
Yeah, right. So C2 dot copy make order, and then I have a handful. You give it the original image.
We actually
Bottom
did
left.
already look this up, but it looks like it was only for applying a colored border around the image.
So it's not actually. So you can say value. Color of border is border type is border color. And so you just give it that give it value equals bracket 0, comma 0, comma 0, so on. So the closest example on there is the last constant equals CV2. So we give the original image, and then
Got it.
Yeah,
yeah.
perfect.
So we can paste that in there. And we can change constant to image, so we overwrite image. So nothing we can that's how Python uses. IMG.
CV2, copy make border.
Yeah, so inside copy make border, we have the image, so we get rid of the one there.
And then we want to make,
The order there is top, bottom, left, right. Now, if our height is greater than our width, we need to increase the left and right. And
this will stay 0, right?
yeah, so the first two are 0. And let's
Alright.
actually create a variable for those two. So let's add a new line. And
So you want to store the value of width. So
Yeah. Yeah. So then, and then each of these is going to be,
yeah, you want to do width equals, or you want a new value that is width minus height.
Let's call it add.
equals,
Python function calls variables by variables without value.
Okay.
So the image on the left-hand side of that equation, that's not going to change the 26, 7,
You want width minus height because in this,
yes.
right.
Okay.
Yeah, so if the height,
Few things.
so if the height is greater than the width, the difference of the two.
Right. Height minus
One
width.
set the difference as, those ends will be had.
Cool. Should we pad over 2? Should pad be height minus width over 2? Should this be though divided by 2?
Oh,
Yeah.
yeah.
Yeah. I used to do this. Well, I didn't code it, but yeah.
And then I don't know that we need,
We don't, yeah. Unless we want to set the value, right? But we'll still set the value.
color, so that's why I'm like, do we need color?
But even so,
Like, do we need the line drawn around it?
but didn't we want to make, we don't want the line, but we could still make that blank space as either white or black. Is that what you're pointing out?
Yeah, so instead of values for blue, we can just give it a list of 0, 0, 0, which is effectively black.
Yeah.
We need a separate case of the odd.
Oh, actually, we can solve that real quick. So do pad, everything that's right of our pad equals line
It's going to be abs.
is rapid and in.
Oh. Well, int's just going to, hold on, everything?
So if it's already an int, the value doesn't change. If it's a float, which meant that the difference is an odd number, it will do Banker's rounding. Either way, we'll still get an image that
Okay.
when scaled down to 45 by 45, will have either no or marginally no distortion.
So after the two processes, they don't have to be exactly the
In our pre-processing pipeline, we're just adding the image right now, but when we're done with adding in the same function, we're going to add the rescale, where it's actually two separate sides. That will spit out a 45 by 45, and my.
How often do we encounter fractional?
You never know. So it's a cheap operation.
If they try to do it odd, then the two processing of the images is tiny bit, not square.
Yeah.
And how harmful is that? When it gets converted to 45 or 45, because I don't know how it's done.
Technically, there would be some distortion, but as long as you have a decent large enough image, having it be 2 pixels thinner than it is high is not going to introduce a significant amount of distortion.
Right.
And it's still going to output an n by n.
By the distortion, you mean you work with the
Work.
image. We can resize all of the images as is, but that would mean that
You
the
get
pattern
really
would look like this rather than this.
Yeah, 2 pixels is nothing.
Yeah.
Compared to, yeah, 500 by 500.
So with this, by casting it, or casting, or in some cases recasting to an int, we either introduce no warping or minimal warping. To the point that's not really
Okay.
So,
Below image.
we're going to do
Enter after
enter.
after image,
Oh.
CDC, copy and order, all this stuff.
Yeah.
Um,
Shift enter.
And it's array with fractional.
Oh, I got it. I got it. And then we want to do what else?
Yes, if else. If else.
If?
No, it's actually just ELIF. So ELIF.
Other than so many different-
Oh, yeah.
I can't
Elif.
remember what it is anymore.
Yeah.
So.
Okay.
Space,
Yeah.
So no tab for this. ELIF operates just like an if statement for the purposes of syntax. Yeah.
W greater than
Greater
than H.
I've seen posts online that say, as long as it does not impact readability, always use greater than, because it would be better.
I feel like that's an opinion that doesn't actually include processing speed.
I don't think it includes processing speed, but as long as you're consistent with, as long as I'm not making my code look weird, just choosing I'm going to do all greater than or all less than.
That's a code discussion that we should have at another meetup.
All right, so then,
Have that, we're gonna do the same thing, except pad is going to switch places and do 2 zeros.
Well,
Yeah.
pad int, and we're gonna do W minus
yeah. All right. Should be, okay, pad's only defined inside of this first if statement, so it doesn't matter if we use pad again. Int W minus H divided by 2. It's going to be half. Image, and it's something CB2. I know. Pad, 0, 0. I actually know what I'm doing for the first time. Well, not for the first time. You guys, I'm copying exactly what it says above it. This is not difficult.
I'm still excited.
Thank you.
For our value equals, we should make that a list instead of a couple. I know it doesn't
Oh.
change, but it would actually append, it would add couples to a list of lists and things,
Nope.
numpy or something else. And that would do something about that.
Okay. All right.
And then if it's the same height,
So the last thing we want to do is return in if.
The very last thing in the same. No.
Yes, outside at the same level.
Yep.
There we go.
That's perfect. So do shift enter, and let's rerun this one.
Just like the
I did. I thought it was thinking.
screen slow.
Do shift enter again.
Yeah, it popped down here.
Yeah. So do shift enter again. So we okay. So word type.
Oh,
Require
you
an border
told me that
type.
earlier, because I was like, you don't need a
Oh.
colored border. And then you were like,
Oh.
actually, so we removed part, so we're back to the
Yeah.
top.
Border constant. CB2.border constant. Is that what we need?
Yeah, that's what we need.
Okay, it's an important part.
Yeah, we don't need blue, but we need that to say we want
Ah.
to set the flag.
Hey, what is like the what's the shortcut on the keypad for switch? No, I know how to do that.
Switching tabs.
Yes, I never can get that.
Alt and Control, and then you can arrow through them.
Oh, that's stupid. I don't like it. Like I like Command Tab because it's easy. It's like my thumb and middle finger, but
Then have this just for open application.
but it didn't used to be that way because you used to have well actually like in Windows you used to have a new window for everything. You didn't have tabs, and then you could just like control tab between everything. And
There's still some windows where if you do the tab browsing, then you have what appear as a different window for the purposes of application. I don't think it's a default window,
Woo!
look at that.
We have some 0 tabs.
What we want.
Cool.
Yeah, so now let's rerun this code block and see what happens to our paycheck.
You have to save that new.
It's not going to update the original image because it's passing in the property. So you can run it as often as you want. We can run it.
No, it's features tab 0 when we are adjusted image.
We're not overlooking anything, so we can.
So we won't see the change.
No, the change won't be saved.
But we wanted to see the change. So how do we see the change? That's what
Yeah.
Let's see what we did now.
Got it.
Yeah.
And I see what you're getting at. So for our tab image at the very bottom, inside of InShow, we can wrap our features tab 0 with our preprocessing function.
Ah.
What is that? Pre-process?
Yeah, preprocess. Yeah, preprocess. And add one more parenthesis. And
We did it.
That's cool.
that's cool.
I love that.
So I'm gonna have you do one more thing before we switch out. So it's
Oh, yeah.
really easy.
Oh, it's me.
That's it.
No. I've been like sitting at home.
We're entertained.
Been there for an hour.
That's what I did for
So, we can, re-sign is actually really easy.
Okay.
It takes one line.
Excellent.
And let
Is
me
it-
double check my presentation on this. But
Okay.
it would just be image equals cdp dot resize, and the first one is definitely image, and I think it would just be 45 comma 45. So let me double check.
Resize. Is that 42 Jesus.
The first one is ENG.
Oh, and this is going to be in our pre-processed function.
That was,
Okay.
Right, is that right? No.
Go back to our,
we're
the
going to,
function that we made earlier.
Oh, hold on. Uh-oh. Holy crap. Where am I at here? Up here?
Yep. So just before our return image, we're going to add a new line. So,
wouldn't you just want to like return the resize information in line?
yes, yeah, I just need to double check it. It actually provides the output. So it's not just provided a single argument. So it would be ING.
So where is he typing? Are we typing as a variable or
Yeah,
add?
we're typing in the right spot here. ING equals cd2 dot resize. And the first argument is ING. The second argument is a tuple that's going to be 45 comma 45.
Did you just do it in parentheses?
Yep.
Okay, 45 by 45 is what? Bracket.
45 comma 45.
Oh yeah, 45 by 45. Ah, not 25, 45. Okay, and that's all?
it.
Okay, so now.
One, you don't have to provide an interpolation. I think it's just on default. Yeah, so there's our
Find
scale
it pixelated, Joey.
Why do we want it so pixelated? Just so we can process everything faster?
It's so smaller.
Yeah.
Yeah.
So there, if you think our current here is
Uh-huh.
45 by 45 by 3.
Yeah.
Which means that in order to use it in our neural network, the first layer is going to have 45 times 45 times 3.
Times 3. Yeah, I get that.
And so if we absolutely can feed in full size,
Yeah,
standard
it's going to
or
take forever.
it
Yeah,
takes
it's not.
forever.
That's what that presentation was like. And I was like following along. Oh, it's
So,
okay. I'm switching out something.
all right. Want to do that? But there is a recording of me. You want to say it. And we'll put the code on GitHub too.
We have the images that are all the right size. Now we can start building our net.
Not yet. We have a pipeline. But now we need to actually apply this to all the images that we have.
No, I never use Max, so,
Scroll.
okay,
And
okay.
Okay.
I'm
So,
going to scroll down to a new colored block below the tab. So we can put it up.
The scroll is like your fingers are on the screen, so if you scroll your fingers going up on the pad, the screen is
The
like on
projector is
Okay.
slow, he's got it.
Well, yeah, I'm learning. Okay.
So you want to go all the way to the bottom of the page.
Okay.
There's
Yeah.
So,
So what are we looking at?
uh, let's do features underscore caps underscore pad.
So in that last code block, okay. Features, underscore,
Pad
Oh,
and equals.
Oh.
Equals, and this is going to be another word confirmation.
so these are certain brackets.
Inside of our brackets, we'll have pre-processing or
Pre-process.
pre-processing. Okay. And let's add
Parentheses.
parentheses, cap. And then outside of parentheses, for cat,
fork.
Yeah, F-O-R.
Okay.
cat in features underscore. And let's run this. That's
Okay.
that's it. What about that? Yeah, that was quick.
It's in a thing. Yeah.
So we can do feature underscore cat underscore pad, or actually we want to do, let's do PLT info.
See.
We can probably just copy and paste the line from above.
Copy and paste the line from above.
And, the one that, Kendall and
Oops. Oh, that's not good.
Control V.
man,
Sorry.
Is there like an undo?
Yeah, and the butterfly and V.
Okay.
there you go. So let's go up to the code block above that one. And our PLT.info, we copy that one.
Okay. Now,
So just do Command A for select all. And then C.
yeah, I'm used to using control.
Yeah, that's one of the ways.
Butterfly V.
Oh, that was.
So back in the other line, Command A. Ooh. Yeah, right there, Command A, and then Command C.
Damn. Oh, I forgot the.
Yeah, it's
Yeah, I forgot the command.
Yeah, it's just like control all in.
Um,
And A, and C, and then this one. There we go. So,
Replace pre-process, feature caps, everything inside those hours of,
actually, we can keep the feature cat.
replace it all. And instead, type inside the feature caps pad, at the underscore, just like you defined above.
Is that it?
Yeah, and then right after pad, add square brackets, and then 0.
Okay.
We'll show us our first one. Go ahead.
Let's change it to a different index. So 40, we looked at 42 before. So let's change our 0 to 42.
Change that 0 to 42.
Exactly.
Now, what exactly am I looking at there?
That is the scale down to the cat. So the 0 or the 42 is the index. So we have a list of all of these different images with all of those zeros.
Oh, so that's
it's like lists and lists and lists and lists.
cat number 0.
Yeah, so cat number 0, we want to look at cat number 42. Sorry. Cat number 42. Poor cat.
Technically, that means we're free.
Oh. Zero indexing. Wow. What we can do now is copy your where we set the featured cat. Yeah, featured cat cat. We want to copy that line, and then we want to do the same thing for dogs. So paste it below and replace everything that says cat or cat with dog or dog.
Like, I don't think we're gonna get to the actual setup stuff tonight, but we can completely finish up our feature set creation, so that the first thing we do when we come back is visit it.
Let's make this open to our. Would you like a little taste of the next thing, or would you like to completely have a clean data set ready to go? Clean data set ready to go. Sorry. Don't be sorry. Your priorities are in the right place.
Yeah, like,
Well, it's actually very good instinct to have, because like if you're going to do a real project and you do what I was suggesting, you trip yourself up so bad.
Yeah.
The neural net you build will be based on the decisions you make when you're setting up your data. So like,
yeah, I definitely don't like clean data, so. Yeah. So like whatever clean data set I can get, that's what I want. That would be one thing that I would say is like the worst task to do.
Data cleaning is like the
It's
worst
awful.
part.
Yeah,
it's like the program of broken.
it is. It's exactly what it is. It's just like the worst task you can do. So
Maybe some people like it. I don't know, but I don't.
There's easy people and they can have that job.
I would actually subcontract them to do that for me.
So, spoiler alert, there are, I think, 3 things that we need to do to have our data set completely ready to go.
Cool.
Number 1, we need to combine our disparate cat and dog features and labels into a single list of features and labels. Or single list for features and a single list for labels. We then need to reshape our list so that we flatten our features. So instead of our pretty list, it just becomes a working list of pixel imagery values. And once all of that is done, or technically we want to do we then shuffle using the sklearn.equals
Shuffle.
shuffle. All right, so this first one is really easy. Features equals features underscore apps underscore pad plus features underscore dog underscore pad. So we know that all of our cats are together. Our list begins with all of our cats and ends with all of our dogs. We'll do the same thing for our labels because they're both the same length. We can still say that there's a one-to-one comparison with both. We then reshape our features. We want to reshape our labels so that it is then a list of one-dimensional lists. And we'll do that using NumPy. So we'll have to import NumPy. And in case you got reshape, we will list and say here's what we want. And finally, we'll shuffle.
Okay, so let's get started by import NumPy. has
Or do you want to combine
we are going to do that, yes. So the next thing we do will be,
and let's run into the water. So that we don't think about
Oh, okay.
yeah, there we go.
okay, the next thing will be features. Features hacks.
Is that underscore?
Cat, yeah. Plural
Yeah,
cat,
this is, yeah, what we're saying.
and then space plus features dog.
So those are both lists.
So that will just kind of smooth things up.
Oh, and we want to use features underscore cat underscore cat.
Okay, so features underscore cat, add underscore cat.
Oh, the same thing with the dogs.
Yep.
Otherwise, we can't dog.
Yes. Can we call them paws, not features?
Oops.
Oh, I don't think cat is
It's just
plural
cat.
for what
Okay.
you want.
Yeah, we just get rid of the S on and then let's just, and let's also just do our
Uh, the,
and then labels equals label cat and what's labels dog.
is that labels underscore? Oops.
Yep. Yeah, so labels underscore cat.
So cats plural.
Okay, so if I'm to visualize like features, this is however many rows of cats, and then underneath is however many rows of dogs.
Is it,
He is
Right.
dog and cat.
is it
This
what
is,
label cats or
so the first,
just for just cat
That's,
and
that's the order. That's what I ordered. All the cats first, and all the dogs second.
yeah.
And then the features are going to be yeah. Okay, and then
Well,
the columns are going to be. Or is it
let me
just
let
one
me try
column
this
and
because
No, no.
nah, it didn't
this
work
is
either.
not a relational
Um,
database yet. So it's not a relational table,
It's just an ordered list. Okay. But
Is
cats
it?
first.
So
Dogs.
oh, label labeled dogs.
so label is singular. We can have that one. Remember to
Is-
make that.
Is the I didn't like Jupyter is the updated version of IPython.
Yes, that's
Right?
Yeah.
Yeah, right.
So they're semi-independent libraries now. If you when you hit install Jupyter, it uses IPython as dependency. Jupyter is the interface, and IPython is the plugin that Jupyter uses to run Python code. You can add other languages to Jupyter notebooks like SQL or I've seen one for Fortran, and you just install it in Fortran.
Is it the same? Is it just a different IDE? Like,
So
or
Jupyter is
might be.
actually serving a version of IPython on an interface to a localhost browser. So it's like providing the UI interface that you're experiencing here, and it's not the same as an IDE.
Even VS Code is not technically an IDE, it's a text editor.
Yeah.
I didn't know you could use Jupyter with R.
Yeah. When on the bottom of the taskbar on a Jupyter, it says code markdown. There might be a couple other options in there, but if you have more than one language plugin installed, you can specify what language you want to run.
it doesn't come that way out of the box,
Right.
but it will.
Because I think with our studio, it doesn't work like a notebook. You can't, I don't think you can go backwards and re-execute.
In our studio, you have, it's,
No,
those are our markdown files, .rmd, and those allow you to insert blocks of HTML and R, or markdown and R.
but you still have to run it from start to end to see your output.
Only when knitting.
Okay, that's what I was thinking of. You can knit your output to an HTML file for display. And that is like a one and done, but in the RMD file, you can go block by block.
Anything is very powerful, but it's also a little.
You could draw that in Echo. How about you place that here?
So what we need to do now is look up the reshape, NumPy reshape documentation, and more likely some specific examples.
So you grab
The plus button? Me command plus? No, that made it bigger.
So with the mouse, you can scroll over to right here and click that. And that'll
Oh,
give you
okay.
10.
Okay.
So now, what are we doing for it, Michael?
So NumPy reshape.
Yes, that's perfect.
Is that big enough for you?
You can do command shift plus, or I think it's just command plus, but
Yeah, the shift.
And I think what we need to do first is we need to add our features and labels to np.md arrays, so the n-dimensional arrays, so that then we can run reshape the features.reshape. Looking at the documentation, the oh, actually, this is just NumPy reshape, but so here you pass it in a list or a NumPy array that you want the original one, and our order, new shape, is how it's going to change, and really there's not a great way to get an intuition about how it works. Generally speaking, you specify a wildcard, size as indicated by a -1 value. You give it a couple, and you can say, I want this many items in this position for however many are in there, and just keep making lists upon new lists. And you can supply one of them to be a wildcard value, which says, gives me n number of blank-dimensional lists. So the thing that we actually need is for our new shape to be a couple of -1, (1), which means I want you to reshape my existing data into n number of one-dimensional arrays. Make sense?
You must learn what you can try again.
Yeah, it's kind of this reshape thing.
Where are we reshaping? We're reshaping just a list, right?
Yeah, so we need to convert all of our lists
one set of brackets with zeros all the way through. Yeah. So that it can process it. It's essentially like one long stream of ones and zeros.
Yeah, and then it's looking at each
Yeah.
item. Okay.
And based on the order, it'll know where one image starts and the other
I
side.
just did this like a week ago.
And NumPy makes this really easy using the reshape. It's just that their parameter syntax to do it is not easy to understand.
So let's look at it and work with it. You got us? You got us.
Okay.
So
It might take like a little while.
Let's do it.
we can start playing around with random values. We definitely do want to convert our features and labels into NumPy.md arrays. So features, we're going to override features here. Or actually, no, we can put into that previous code block our features and labels. So our features equal features X. And let's wrap our existing condition code in NP. NP.NV array. Just like that. And we'll do that, we'll run that, and we'll do that for the labels as well.
Now, the documentation said that does the same thing with reshape.
So we're casting this. We're just casting this to a new array type right now. Because, funny enough, both Harris TensorFlow and a lot of sklearn models really prefer to have, did we have a or we have one before?
Well, I don't think you can capture the
Okay, then I guess we can just override features.
That's where it was before.
Now our new one will be features equals np.new array features.
So in our blank code block below.
Oh.
Or just below that on
NP dot
NP array.
features. Same.
And we look up the documentation for NP array.
Or maybe we just get rid of NP and have it be array. So NP dot array instead. We'll still get reshape that in
Yay!
Alright.
Sometimes settling is the right answer.
And then so now we'll do the same thing with labels. Labels will do with np dot array. I think it's the option basically. No high growth that. But and I'll probably use in analyze everything as well. All right. So now we can do features equal. Now we can not override. Let's do print. Features dot reshape.
Features dot reshape.
Or yeah, reshape. And then in parentheses, we give it a couple. For the sake of example, let's do. I think we need -1 minus 1, but for the sake of example, let's do -1 plus -1 comma 2 comma 1, and you see that 2 of the
to ignore all of your existing boundaries and just run through all of your embedded raw data values, and then just reshape to look like what you say.
Oh, I have a good algorithm.
Okay.
So it's like looking at strings, and you have string, and you can split on either commas or things, or you can just pass in some split every third character, regardless of what that character is. So in this case, we're taking our list and assuming that the data points within those lists is all that we care about, and right? That was nice. Appreciate that.
So I think we just get rid of the 2 in our couple there.
I replace it with what?
You should get rid of it.
Okay.
So it would just be, it would just be that. Let's run that and see if this is the way we want it.
Did they both make an idea one?
No.
So we still need them, we don't need them all each in an individual. Make the second be 0.
I don't think
Try it.
I don't think it takes 0. It would be an error, but we can try that.
So the positive one make it 0.
And what does that 0 mean?
That's what we're trying to determine.
Okay.
We don't know how you use it.
That's the error.
Okay. So it's not a valid. Maybe let's just give it a negative 1. Let's see what that does. So now try just passing one parameter, one negative. So you did it.
Why did we start at -1?
So -1 is wildcard. That's -1 is used as the wildcard. You're only allowed to have 1 in each reshape couple. And then just says that based on all the other data, just make n number of entries that satisfy the other requirement.
What do you mean by wildcard?
Replace with n.
Okay.
Yeah, it would
That
just
makes
be
sense.
like saying, as long as you make
It's
the
just-
other values fit,
Yeah.
I don't care what you need to do.
It's a count of how many values are in the data in the.
Yeah, so if you were reshaping the list of 0 through 9, and you said you gave it -1, -2, then it would give you n number of lists of length 2 that satisfy the data you have.
Oh, features is the list of the images of cats and dogs, right?
Yeah.
And what Reshape did is, and each of those images is a list of 0.
A list of 0 or 1.
Okay, but and the Reshape gets, like you said, gets rid of all the commas and brackets and everything. But those images aren't all exactly the same size. They don't have the same exact number of pixels.
They have them. We've added them. We've added them and reshaped them in our 3 process.
But some of them might have a slightly different size. Like they might be off by.
But
Oh, did you do the?
Yeah, the
after
resize,
we resized
they
it,
are,
they're exact.
at this point,
Okay, so they're all like
45.
45. Okay.
Right, yeah.
Yeah, I forgot that part. So they're all exactly the same size.
So
I'm reminded that the first layer of the Keras network actually has shape equals shape. So I'm thinking I'm actually wrong, and we can just keep the feature set active. And we should say that this one has real performance left. So we can keep it there for next time. But what we should do right
that out.
Oh, dang it. We need to get track them down.
So what we should do now is we have what's called a data checkpoint. We've done all of this stuff to our data, and as fun as it would be to redo it next time. We want to do that. Yeah. Well, the floppy drive only saves the info. We want to save the data. So we can export our existing features and labels to pickle files.
Pickle!
So for that, pickle is pickle is a library that just says take my raw Python object and export it as a binary file. R and everything has something similar. Yep. So you actually let's do from pickle and spell it just like you do. Import dump. Yep. And now we just do dump. And the first one is going to be file object, so we use open. And in parentheses for open, we give it a file name, so let's do features.pkl. Oh, and it has to be string.
Specify a string and quote.
Oh, okay. Double quotes like that, or?
It'll interpret both single and double quotes as
Features dot.
.pkl. And then our second argument is going to be, the string is fine.
That's perfect.
Oh, okay.
Outside the quotes and add a comma. Yeah.
Yep. And then our file mode is right binary, so we get a new string, W2. Yes, and then actually for dump, the first argument that we have is actually the object that we want to pickle. So for open, we'll put features and add a comma. So then open becomes the second argument that we're passing to dump.
Can you run that by me again?
Okay, so type features.
What,
So inside
Right,
the
right where it is,
right where the cursor is?
And add a comma.
Oh.
And I can't count is dump.
No.
Okay, we need to add parentheses for dump is really
Okay.
yeah, you're right there with the comma. It's just you need to put everything in parentheses. Yeah.
This looks like success.
Okay, now run that. Now copy that line, copy our previous line, and you just replace features with labels.
You are now allowed to
Dismissed.
sprint out of the room.
Here
This
we go.
is the bonus points territory here.
Last little bit, let's just make sure that it actually works. We
Slow down. We won't succeed faster by talking faster.
So actually, well, we're done with the code. The tab just to the left of our current tab is our notebook home page, which is in the directory, and we should see features.pkl and labels.pkl.
Click somewhere else. Yeah, click somewhere else and that'll get rid of things.
That home, the one that says home?
Yep.
Did it again.
You doing it two
Click,
pages?
yeah, click with single.
Just one.
There you
There we
go.
go.
Woo! There are your files.
There's our
Oh my
okay.
gosh. Okay, so by the way, everything that we just did right now is just basically what being a data scientist is. Like, I don't know how to do that. Let me Google it
Yeah.
and then fit it in there.
This is what being a
Okay.
programmer is like.
Okay.
This is every day.
I don't know what this is. Let me Google it. Let me look on Stack
Often
Overflow.
in mob settings, lots of companies do this
Yeah.
kind of programming style.
Well, it seems effective. I mean, we've made more progress than probably any of us could. I mean, no, that's not it. Then I could have done my own. But,
And
that's
also,
cool.
Also, this is why I keep around all of the code that I've ever written that is not
I keep around all the code that I've ever written that I'm still allowed to keep. Because I have
Because
done
you can,
this
like,
before,
access
so I can
it.
reference it.
Oh, that's
I
like
know that this works.
all
Let
my
me
notes from
just
college
copy
are
and
gonna
paste it and
keep
rework it.
around. Like I'm never gonna look at them again.
So yeah, that's it. I will take what we have here and pop it into a Git repository. Orlando MLDS has its own GitHub repository. It is its own organization, so it'll just pop it up in there. I'll share it. I'll post a link as a comment in the role.
And that's open for anybody to
Can I? Sometimes, okay, so I don't understand the GitHub thing, but I can basically like fork any of that stuff to my GitHub, right? So that I can like use it if I wanted to keep working on this.
You can make pushes to this one if you continue to work on it too. Like you don't have to keep this to the side. You can do that too. You can also make pull requests to the main one. That's the whole point of open source is that anybody can help work on an open source project.
I'm not there yet, but okay.
Is there like a GitHub for Dummies guide or something?
Let's
On YouTube, there's some good ones.
intro the next meetup. For, yeah.
Haven't we talked about? We did talk about GitHub for one of the.
Ooh, oh,
Meetup.
excuse me. Hey, we're doing it next Tuesday.
Let me look at it.
Okay.
Fun.
Well, the reason
Oh,
is
it works.
it's okay, that's fine. So I'm scheduling the Lady Guns meetup.
Oh,
We currently don't have a topic, but like, if you're gonna get really great.
yeah, that would be good.
The meetup would like to be at 7 p.m. at Coastal, which has free parking. It is down that way on south a little bit. It's like, yeah, you are also welcome. Lady Guns is an open community. So we'll
It's a
talk
little
about
bit
it.
Yeah, that would be helpful. There's just, you know what, and it's not that it's hard, like, I think, honestly, for me, and you guys can probably tell from the things that I say, like, sometimes just, like, outlining A, B, C, D, and then watching everybody shake their head is, like, really, really, really helpful. So, I mean,
A very solid strategy of how to solve problems. You first outline what you want to do and then start applying it to your code. And checking with other people. Hey, this is
When I get some free time, I will clean up the notebook a little bit, add some markdown sections and describe what's going on, and probably not next month, but maybe the month after we'll pick up with this.
cool.
Thank you guys so much. This
No,
was
thank
awesome.
you.
Yeah, this was really good. I'm glad that it's kind of nice that it was a smaller group, too.
Yeah, Mom does work a little bit better with smaller groups. Yeah, it can
Yeah.
handle big okay, as long as everybody's like,
Yeah.
knows how the process works.
Isn't the axiom like a group of 7 or more? There's like there's a number. I haven't studied this before.
Let's give my computer a break. Hi, live stream.
Okay, so.
Bye, guys.
Did I make it?
Yes, you did.